All right, we're doing 6-2. I think this is where things start getting a little bit more exciting. Get my computer all set up. And I think you're going to like this. All right, so first of all, if you want to get full credit on your homework, you have to show your work. So kind of what I'm expecting is what you'll see here in the notes. Do it that way, get full credit. So here's the steps. Steps will make more sense as we go through and do the problem. So I might read through the whole thing. I'm not totally sure. But we have the step number, or the asterisk, if necessary, solve one equation for one variable. So if one of them isn't y equals something, that's the way it normally will be. Sometimes it'll be x equals something. Then first make it y equals. But then our steps, substitute, well, let's just go through to example one. Let's do example one following these steps. So our little asterisk thing there, that's already done. We have them both actually being y equals. And this is the one that, in theory, I think is often easier, but it messes up a lot of people. But we're saying this, we know that y and 3x are the exact same amount. So if those are the same, and we have a y here, we should be able to put the 3x and substitute it in, put it in for that y right there, because we know 3x and y are equal, they're the same thing. And when we do that, we'll get a 3x equals 5x minus 10. So what we just did when we substitute, you can think of like a sports team. When you substitute something, one person goes in for another and replaces another. That's what we just did. We replaced the y with the 3x. But now we have one equation there in kind of that tealish color that only has one variable. There's just x's. So we can solve that. And we could take and either move the 3x over here to this side and then move the 10 to that side. I'm just going to take and deal with the negative. I'm going to subtract 5x from both sides. But which way you solve it doesn't really matter as long as you don't violate like a math rule. But because it's a positive 5x right there, I'm going to subtract 5x from both sides. When I do that, I have negative 2x's on the left. On the right side, my 5x's drop out, and I'm left with a negative 10. Because remember, the signs go with the number that's behind them. So it's a positive 5x and a negative 10. All right, then to find x, x is multiplied by negative 2. The inverse, or opposite, you could kind of think of it. Multiplying by negative 2 is to divide by negative 2. That'll cancel those out, and I get an x equals 5. So in other words, if I were to go through and graph these, and I wouldn't actually bother with this if I were you, we have one line something like this, we have another line something like this. We know that the x value here, where those two meet, is going to be a 5. And we just want to find the y value, because once we know the y value as well, we have the point where they meet. That's the solution to the system. And I could do that. Let me erase. Oh, looks like I can't erase my stuff at the top. But we could use either one of those equations to do it. I'm going to say this equation looks easier to me. So if I have y equals 3x, I'm going to take my 5 and just pop it right in there for x. And I get a 3 times 5. And I know you probably did this in your head already and found out y is 15. But I'm looking for you to show your work, so please go and do that. But my final answer then is going to be 515. Now to check your work, we know, unless I made a mistake right here, we know that it works now for this line equation. So we know then that that point is on this line here. That's my one that should be going through the origin. Kind of did a bad job graphing it, but we know it's on one line. We want to make sure it's on the other line. So to test that, to check your work, really should do the second line equation, y equals 5x minus 10, and figure out, is this point on that as well? And this goes back to what we did in the section 1 work. We take y and the 15, put it in for y. Take the 5 from my point, put it in for x. And then I'm going to be looking for you to kind of show each line after each step. So 15 equals, we do order of operations, so 5 times 5 first is 25. So we get a 15 equals 25 minus 10, 15. So good. So we know it should work for both line equations. If you want to go back and recheck it with this one, you can. But more figure, if you use one equation to find the second variable, then you could just check it with the other equation. I really should have been going through the steps up above in hindsight, but if you look at what we did this first thing. We substituted the 3x in for y, so we did step 1. Step 2, we found the variable that was left. We did that. We only had an equation with just x's, so we found what x was. Step 3, we used x being 5 to find the other variable. We found y is 15. And then step 4, we checked our answer. So that's kind of working through the steps there. if we were to do example 2. Example 2, it seems like most of them look more like example 2 than they did example 1. But it's really, really similar. That they give us, all right, we know y equals this thing right here. So if those two are the same, we could take that and replace this y right there with what I circled, that negative x plus 29. So I'm going to rewrite my problem. I have an x minus 2y. So I have my x minus 2, but instead of the y, we need to put in that new what we know y equals. So that's a negative x plus 29. So that y is now what's in the parentheses, and that equals negative 22. That's really the only new part of the section. Now we just go through and we do the algebra we've been doing for a long time. We just solve for your variable. And to do that, I'm going to distribute my negative 2 there. So it's a negative 2 times negative x. Sometimes that negative x messes people up. You can think of it as though it's a negative 1x. So I get an x, negative 2 times negative 1x gives me a positive 2x. Negative 2 times positive 29 will give me a negative number, that'd be 58, so negative 58, equals negative 22. Alright, I can combine like terms, so I have 3 x's minus 58 equals negative 22. Now, next step in solving for x is to go through and try to isolate the x doing order of operations backwards. So first we're going to add 58 to cancel out that minus 58. I'm left with 3x equals 36. I'm doing the math right. I'm not doing the math right, we'll find out when we check it. So, all right, divide by 3 on both sides. And x equals 12. So we have that. Now we could go back and we could put that in either one of those equations at the top. It doesn't matter which one. That first one is going to be easier just because it's y equals. We're trying to solve for y, and it's already solved for y. So we can just punch our x in over here on the left side. So negative 12 goes there. And now we don't need to move things around to the other side because it's already y equals that number. So y then is going to be 17. So my solution then should be the point with an x value of 12 and a y value of 17. But to get full credit, we're going to go and check our answer. So we know that this should work unless I made a mistake in this step, kind of really this step here. We know that it works in that line equation. So we want to try it in the other equation. So x minus 2y equals a negative 22. So my x was the 12. Minus 2 times 17. You don't need the parentheses, you could just do 2 times 17 there. Equals negative 22. So I get a 12 minus 34 equals negative 22. Trying to show one step at a time so I can get full credit for checking this. 12 minus 34 is going to give me a negative, and sure enough it's a negative 22. So once we have that, a little check mark by it, yep, it works. So we know then we found the correct answer right there. So that's the second example. Most of the ones you're going to see are going to look more like that. But we could have a story problem as well. And the only difference with a story problem is you have to come up with your equations and then go through and solve them. And if we were to do this, so Uncle Edgar opens his new clothing store called the Fashion Farm. If 4 shirts and 3 pants cost $420, 1 shirt and 2 pants cost $205. What does the cost for a shirt cost for a pair of pants? And sometimes with story problems, your brain starts swimming. So you could just jump right to the end at least to figure out what are we trying to find. We're trying to find cost for a shirt and cost for a pair of pants. Some people do X and Y. They're more comfortable solving for X and Y. I'm going to go through and say S for shirt and P for pants. Then when I get done, I don't have to try to figure out, well, what was X again? Was that the pants? Was that the shirt? All right, so our 2 equations are going to come from these 2 lines here. 4 shirts and 3 pants cost $420. Well, 4 shirts, if each shirt was $10, it'd be $40. So we're just going to do 4 times the cost per shirt. Well, if the cost per shirt is this S right here, we could just do 4S for that part. So 4S is going to be the total cost for shirts. And 3 pants, so that'll be 3P. So total cost for shirts, total cost for pants, $420. So we add those two together, we get that. Now our second one, we have, I'll switch to blue, we have 1 shirt and 2 pants cost $205. So we could do S, or 1S if you wanted to, plus 2 pairs of pants would be 2P equals 205. So we have our two equations, and we go through and solve it just like before, but that asterisk thing at the beginning kind of comes into play now. Because where before we always had a y equals something, and then sometimes you'll have an x equals. We don't here. We need to solve for either s or for p in one of the equations. The one that's going to be easiest is this one here on the side because it's just the 1s. So we can solve for it in really just one step. And to do that, to get the s by itself, I'm going to subtract 2p from both sides. That gives me s equals 205 minus 2p. So once I'm there, now we can substitute. And typically, you're not going to have to do it this way. You're not going to have to do what I just did, this solve for a variable. In this section, yes, you might have a few. I don't remember what I assigned for the homework. But generally, if you have equations like this, where neither are solved for a variable, you learn a cooler way to do it in section 3, called linear combination or elimination is what our book calls it. All right, so we have our s. Our s value then equals 205 minus 2p. So I'm going to take and I'm going to put that right there for s. So I get 4 times 205 minus 2p. That's my s value there in the parentheses. And I add 3p equals 420. Really, I'm just copying the rest of that equation, just copying things down. 4, I have my s. And now we have an equation that's big and ugly, but the only variable in it is a p. So we can go through and solve for p. So I'd start by distributing. That's going to be easiest, I believe. And 4 times 205. So 4 times 200 is 800. 4 times 5 is 20. So 820 minus 8p plus 3p equals 420. So now that we got rid of those parentheses, we could go through and combine like terms. So I have a negative 8p and a positive 3p. It's going to give me a negative 5p. So 820 minus 5p equals 420. Now we go through and do an order of operations backwards. We have this positive 820 hanging out over here. It's connected by this subtraction right there. So we want to undo that 820. So I subtract 820 on both sides. I'm still left with a negative 5p equals negative 400. Divide both sides by negative 5. Like that. Divide by negative 5, divide by negative 5. My negatives will cancel, and I have 400 divided by 5. So 80. A pair of pants is $80. This truly is high fashion at the fashion farms. Okay, so pants are $80. And then I don't know if we were doing our ordered pair as like S comma P. So you could put like 80 over there, but you at least want to know that pants cost $80. And once we're there, we could take and plug this into either this first equation here at the top, plug into this equation here in blue, or this equation should be the same as this one, which is already solved for S, which is what we need. So I'm going to take and put this 80 here right in for P. And I'll write it off to the side a little bit, but I have my 205, maybe I should do S equals 205 minus 2 times 80. So 205 minus 160, so $45 for a shirt. So $45 there. And once we have that done, we just need to check our answer and we'll be good. Good. So we found the 45 over here on the right in this blue equation, which I'm going to make the assumption that this and this are the same. So I just need to go back and check it in the other equation because we know that 45 is going to make 80 work in this equation. So we check it over here. So I'll maybe switch to black and say 4s. So 4 times 45 plus 3 times p, which was 80, equals 420. So 4 times 45 would be twice 90, so 180 plus 240 equals 420. And then I have my equals 420 still. If I combine those two, I get 420. So we are good. If you do get through a problem and you find that they don't equal, that's where it's like, oh no, and you have to just kind of figure out where to start. You go back and look for a mistake. Sometimes it's easier to start over. That's all I have for you. Let me know if you have questions. I'd be glad to help. Thanks for listening.